Hi everyone, my name is Xinwen Zhang from Animal and Food Sciences Department. So today I'm going to present my poster research. The title is Extrogenic Activity and Developmental Toxicity of Potential BPA Replacements, Lignin-Derivable Monomers, using in silico, in vitro, and in vivo methods. So first I will introduce some background information. So bisphenol A is an organic synthetic compound and has been widely used in the production of epoxy resin and polycarbonate plastic as food packaging. In the past decade, more and more convincing evidence of negative health impact of BPA has been reported. This also include for the commercial bisphenol analogs, such as BPA. Therefore, finding BPA alternative with low toxicity are crucial to ensure the human health. Lignin cellulosic biomass, which is a sustainable resource, has drawn attention to bio-based polymer researchers. And also this monomer has been reported with promising thermochemical performance. So in this study, we include 3 newly synthesized lignin-derivable monomers. They are BGF, BGA, and BSA, as shown structure here. So we want to evaluate the potential extrogenic activity, EA, of these compounds in comparison to BPA and BPF. BPF is just one commercial bisphenol analog. And also investigate their potential developmental toxicity using an in vivo chicken embryo model. These two are important toxicity endpoints related to BPA. So here shows our methodology part. Basically, we have 2 in silico methods, one in vitro cell-based assay and one in vivo model. So for the first part, we target on the EA. We use the in silico molecular docking to predict the potential binding affinity of this compound to different human nuclear receptors, including the estrogen receptors. And then we apply this MCF7 cell proliferation assay to further quantify the extrogenic activity of this compound. At the end, we also have an in vivo chicken embryo model. We target on 2 estrogen responsive genes, APO and VTG, target on their hepatic mRNA expression level after treated with this compound. At the second part, we target on the developmental toxicity. We first use the TST software to predict the potential acute toxicity and developmental toxicity of this compound. And then we will use our chicken embryonic model. Basically, we will inject this compound at different concentration into the eggs, and then we will observe the mortality, malformation, and other developmental index, as well as the oxidative stress level in the chicken embryo to reflect the developmental toxicity of this compound. So let's move in our results part. This part are showing the results related to developmental toxicity. Basically, these 3 lignin-derivable monomers, they show the similar level of developmental toxicity compared to BPA and the BPF. One interesting thing we find is like BPA has a non-monotonic dose response curve in the chicken embryo model, which means it has a higher mortality at both lower dosage and higher dosage. And these BGA, BGF, and BSA, they all cause some death embryo in this model. And also they increase some T-bars level, which is an indicator of the oxidative damage. Here is about the extrogenic activity. Basically, in this docking results show that the BGF and the BSA had a lower binding affinity to estrogen receptors compared to BPA and the BGA. In our cell proliferation assay, also further confirmed that the BSA and the BGF has lower EA compared to the BPA, BPF, and BGA. But for our hepatic mRNA expression level results show that both three compounds, including the BGA, BFA, BSA, they all have significantly lower expression level of the APO gene compared to BPA, which indicate that they lack this estrogen response in the chicken fetal liver. So in conclusion, we found that these three lignin derivable monomers showed lower EA concern compared to BPA, while still had slight developmental toxicity in chicken embryo model. So overall, they are good candidates for BPA replacements. Thank you.